Hello everyone, my name is Mr. Burke. I am a teacher of statistics at many community colleges in Southern California. And we're just going to look at a few sample problems to discuss how we develop confidence intervals for one proportion. And to help us with the calculations for this, we're going to go ahead and use a graphing calculator. So this is not meant to teach you the topic from beginning to end, as my class currently has some online instruction to explain the background of this. But this is to just go into some type of application problems to show students how to read the problems, how to get the information out of the problems, and then use the graphing calculator to obtain the solutions and then write the interpretations. So here we go. There are three problems that are from the textbook, and they're located in section 7.1 of the Triola California 2nd edition for you to reference. So the first one is Mickey D's. In a study of the accuracy of fast food drive-through orders, McDonald's has 33 orders that were not accurate among 362 total orders observed. Construct a 95% confidence interval for the proportion of orders that are not accurate. Okay, so here we have the number of orders that are not accurate and then the total number of orders. So if we're doing the proportion that are not accurate, we want to make sure we have that number. Okay, so for this data here, our x value, that's the number of orders that are not accurate, is going to be 33. Our n, which is going to represent the total number of orders that we're considering, is 362. And then the confidence level, which I'll refer to just as CL, the CL is equal to 0.95. And that's exactly how we're going to put it into the calculator. So how we do this on the calculator is we're going to go ahead and we're going to just turn the calculator on. We're going to go to Stat. We're going to go over to tests, and we want to do, because this is an interval, we want to do what's called 1 prob z int, or just sorry, maybe in this calculus. So these calculators are fairly new. So yeah, here we go. So there's 1 prob z int is choice A on this one here. So I think it's on most calculators that is the case, but this is like a newer calculator. It's color. So we go here, and you'll notice there are three things that are being asked for, and that's these three things right here. The x, which is going to be 33, the n, which is going to be 362, and then the confidence level, which is going to be 0.95, which is a pretty universal kind of a confidence level. We calculate, and we get the following output, which is going to be kind of important. So first off, there are a couple different ways that we can write a confidence level. One way is to write it in parentheses to show the lower bound of the confidence level and the upper bound of the confidence level. So we'll just write what the calculator gives us, which is 0.06151, comma, 0.12081. So this is one form in which we can write the confidence level. What I usually look for my students to write is I usually look for them to write the letter P in between. And what we want to say here is, because what does P represent? This represents what we think the true population proportion is going to be in terms of the number of mistakes that are, the proportion of mistakes that are made when making a order at McDonald's. So what I'm going to do with the values here, though, is I'm going to go ahead and round these to the nearest 3 decimal places. That's the usual requirement when writing a proportion. So if I round this to the nearest 3, this is 0.06. That's 1, but that's 5, so this is going to have us rounded up to 2, so it'll be 0.062. And then we go to 0.120, but after the 0 is an 8, so we're going to round this up. So this could be 0.121. So what we're saying is that the true proportion that we believe that we are 95% confident that the true population proportion of mistakes that are made at McDonald's in the orders is somewhere between 0.062 and 0.121, or if you put that in percents, is like 6.2% to 12.1%. So we're going to have to write a conclusion about this. We're going to write the following conclusion. We are 95, and this is based on the confidence level, 95% confident that the true population proportions of mistakes in drive-through orders is from 0.062 to 0.121. And that's it. So a couple of the things that you may be interested in calculating possibly is what the sample proportion is. And if you want to calculate the sample proportion, that's going to be p hat. That's going to be equal to x divided by n. So if I take the calculator here and, oh, you know what? Actually, I take that back. I think if you put that into the calculator, let me go up to A here. I think the calculator actually provides you with this, if I'm not mistaken. Yeah, so if you look here, it gives the p hat as 0.091, so we'll go ahead and round that here. So the sample proportion is this 0.091. And again, like the other values here that we use on the confidence interval, we're going to round this to the nearest 3. So the sample proportion is given on your calculator, but another thing you may be also asked to find is the margin of error. And a quick way to find the margin of error is to go ahead and to take the parts of the confidence interval. We're going to take the difference of these and simply divide by 2. So it's going to be equal to 0.121 minus 0.062, and we divide that by 2. And if we do that, so let's go and clear that out. So we'll take 0.121 minus 0.062. Now if you do this, you don't want to just do this and then divide by 2. Either put that in parentheses or hit enter and then divide that result by 2. And you get 0.0295. Now if you were to write this to like the nearest 3 decimal places, this will round to 0.030. But I just wanted to show what, the value the calculator generated on that. So that's our first example to show how we handle the first problem regarding confidence intervals. Let's go ahead to problem number 2 and see how we handle that. Now the last time we need to move the paper up. So the second problem addresses medical malpractice. And it says, in a study of 1,228 randomly selected medical malpractice lawsuits, it was found that 856 of them were dropped or dismissed based on data from the Physicians Insurance Association of America. Construct a 95% confidence interval for the proportion of medical malpractice lawsuits that are dropped or dismissed. So in this case, this is going to be the x value. If this was for the value that weren't dismissed, we'd have to take the difference of these two. But this is asking for the proportions that are dismissed, and this is the number that are dismissed. We can let x equal 856, and it's going to be the total sample, which is 1228. And the confidence level in this case that we're going for again is 95%, let's say 0.95. So we're going to go ahead and put those numbers into the calculator again. Go up to A, to 1 prop z int, and we'll just type the numbers in. 856, comma, 1228, comma, confidence level 0.95. We're going to go ahead and calculate this. And you'll see here again, we're given the sample proportion. We'll go ahead and put the information down here. So the p hat, that's equal to 0.697. And the confidence interval we obtained from this is 0.67137, comma, 0.72277. Now, when you're doing your homework online, as well as the test and everything, you're going to notice it's going to specify how many decimal places it wants it rounded to. The common practice is to round this to 3 decimal places. So again, this is one way to represent a confidence interval. And we use the sample proportion to estimate the population proportion. So let me say that one more time. We use the sample proportion to estimate the population proportion because we can't ever really know what the true population proportion is. But based on the sample proportion, we can get close to get a good estimation or close estimation of the true population proportion. So what we have for p is not an exact value, it's an estimate, meaning that the true population proportion is somewhere between these two values. Rounding this to 3 decimal places again, this is going to be 0.671, and this is going to be 723. So what we're saying here is that we believe that the proportion of cases that are the malpractice cases that are dismissed is somewhere between like 67.1% and 72.3%. So an interpretation of this is to say we are 95% confident that the true population of dismissed lawsuits or dismissed malpractice lawsuits is between 0.671 to 0.723. And you'll notice here, what are the things that are going to change from question to question? Well, that number is going to change because that is directly tied to the confidence level. What's going to change is the context of the question. So that's going to change. And then, of course, the numbers here are going to come from the confidence interval themselves. So that we are blank confident that the true population proportion of, and we're going to say that again, so this is going to be the same, this is going to be the same, and think in between, that's going to be the same. So when you're looking at these sentences, you'll see some commonality here. So there's some framing that you can utilize to help you write a solid interpretation of the question. So when you're putting this together, it is true to what confidence intervals are saying. Okay, last question, Lipitor. In clinical trials of the drug Lipitor, 270 subjects were given a placebo, and 7 of them had allergic reactions. Among 863 subjects treated with 10 milligrams of the drug, 8 experienced allergic reactions. Construct the two confidence interval estimates of the percentages of allergic reactions. Compare the results. What do you conclude? Okay, so we'll go ahead and do both of these here. But you'll notice that the first one's the same. So there are 2 trials. So let's go ahead and divide the paper up. This is going to be, and I'll push this up again. This is going to be trial 1. It's going to be trial 2. So in trial 1, the N is 270. The X is 7. And I believe, so it's 95% confidence again. So C level, CL is equal to 0.95. In the second trial, it has 10 people having allergic reactions. That is a distractor. It is not 10, it is 8. So N is going to be equal to 863, and then the confidence level here again is going to be 0.95. So we're going to generate the p-values here, or the, I should say, the point estimate on the calculator. They're also going to be writing the confidence intervals for both of these, what the calculator calculates. So let's go ahead and turn this on now, and we'll go to stat again. Okay, and we'll just type in the numbers as we have them. X is 7, 270, 0.5. We'll calculate this. So here we have, these are fairly small decimals here. We'll put that down as 0.00697 to 0.04488. On trial 2, we'll go back. And we're going to change the numbers, the first number to 8. That's going to be, oh, did I put the numbers in? Yes. That's going to be 8. It's going to be 863. And here we get the following numbers here. This will be 0.00288 to 0.01566. Okay, so we'll go ahead and just take a look at these confidence levels here. I'm not going to write the interpretation of the statements here. but we're just going to look at interpret this a little bit. So if I write these confidence intervals using P for what we estimate the true population proportion being, I would go ahead and write this first one as 0.007. This will be 0.045 using rounding. Here this will be 0.003 to 0.016. So you'll notice here that the lower boundary for this is 0.007, this is 0.003, the upper bound for this is 0.045, and the upper bound for this is 0.016. So this one has a wider confidence interval that I believe is largely because the sample size is smaller. This one is a much more narrow confidence interval because the sample size is going to be a little larger. It has to do probably with the sample size, and then we didn't get like many more people who had positive. Like here was 7, here was 8. That's one more. But this is 270, and this is like more than 3 times 270. So we take a look at this here. They do share some common space, so I think it's fair to say after these two trials that clearly there are some people going to have a reaction, but it's not going to be any more than like 4.5%. This one says it's going to be even less than that. So based on this, we probably can conclude that the numbers are going to be fairly low within maybe the 1% or 2% range. So, also the point estimate, which I forgot to show here. Whoops, hold on. This one here is 0.009. And I didn't get the first one, but let me go ahead and go back and do that again just to make sure that I get that one. Okay, so I'll make that 7, 270. Okay, so this is 0.026. Okay, so pretty small numbers overall. So the big thing I wanted students to take away from this is what information do we extract from a problem, what do we need to write down, and how can we use the graphing calculator to generate the confidence interval, round it properly, and then write appropriate interpretations of the situation. I hope this is helpful.